Palo Alto entrepreneurs Dave Packard and Bill Hewlett decided the name of their new electronics company today by flipping a coin. Bill won the toss. The new firm's name is Hewlett-Packard.
The Wave of Innovation Mobile Museum was created to provide employees with a look at the history behind HP's unique culture known as the HP Way, and to tell the story of HP's Corvallis division and their efforts to produce the first marketable inkjet products, the St. Helens pen and ThinkJet printer. The story of inkjet invention, however, goes well beyond Corvallis. The halls of HP in Vancouver, Washington, Boise, Idaho, and San Diego, California all echo similar stories of trial, triumph, and discovery. Innovation has always been vital to HP. From the beginning, Bill Hewlett and Dave Packard worked to develop an organization that would engender creativity. As Bill Hewlett noted, the type of close relationship that existed in the company encouraged a form of participatory management that has carried on to this day. We solicited ideas from wherever we could get them. The net result was all felt they were members of the team. Starting in 1957, 7 key objectives were developed that would come to be known as the HP Way. Among those objectives were trust, contribution, flexibility, and commitment. For Bill and Dave, one corporate objective was always paramount, the desire to make breakthrough technological contributions. That desire to stay ahead of the pack took HP to Corvallis, Oregon in 1974. Establishment of the Corvallis site was a direct result of the innovation and drive of Bill Hewlett's personal vision to produce the first handheld scientific calculator. In 1972, with the introduction of the HP 35, Hewlett-Packard was on the leading edge of technology. Prior to the HP 35, anyone involved in science, math, or engineering carried a slide rule. With the 35, the business of making slide rules virtually came to a standstill, and overnight the HP calculator came to be known as the electronic slide rule. That same pioneering spirit that led to the development of the Corvallis site would eventually carry over to the development of the first marketable HP thermal inkjet products. But the roots of thermal inkjet technology can be traced back to engineer John Vaught, who was with HP Laboratories at HP headquarters in Palo Alto, California. Around Christmas in 1978, John Vaught and colleague Dave Donald decided that a 200-plus drop-per-inch inkjet printer would be a Christmas wish come true. They also agreed that such an invention was little more than a pipe dream. John decided it was time to make it a reality. The two men experimented much over the next several weeks until they were able to ignite a spark strong enough to vaporize ink and eject a droplet. Soon they would hit upon replacing the spark with a small resistor that acted as a heater. Developing that groundwork into a workable product design attracted enthusiastic engineers and managers from several HP sites. Vancouver, Boise, San Diego, and Corvallis all joined HP Labs' investigation into the potential applications of thermal inkjet technology. These early investigations would provide a foundation for many later inkjet products. In putting together the exhibition, the designers asked, what does HP innovation look like? That question received some strange answers indeed.
Life in Frank Cloutier's technology trailer. Rain in the windows, rain on the way, rain in the door, mice on the floor, and cafeteria trays.
Clever, determined, original, and wacky are the words most commonly used to describe the teamwork of early inkjet engineers as they begged and bartered for space and supplies.
Well, we ended up in the trailer because at the time, this is in late 1980, there was a lot of expansion going on site, and space was at an absolute premium. There was no covered hallway connecting the trailers with the rest of the building, so that's why there's the rain quotes. And the trailer had this cute little feature where there was a rain gutter that sat above the door, and it would accumulate a certain amount of icy cold, dirty rainwater. And there was some quirk of its construction whereby when you opened the door, if you weren't standing in a carefully chosen spot, it would dump several cups of dirty, icy cold rainwater down your back. People ask the question, why the pink flamingos? And it was our unofficial trailer mascot. When somebody new would join the group, we'd present them with a pink plastic flamingo. Every Friday was tie day. And the rule was that you had to wear a necktie, and if you didn't come with a necktie on, you had to wear one that I gave you.
While this Corvallis team was in the early stages of development, Mount St. Helens erupted in Washington. From then on, the pen and the team were known as the St. Helens Project. Ink chemistry, back pressure, pen architecture, and fluid channels are all pieces of the technological puzzle that the team was trying to solve.
On a patent form, it says inventor, okay, very clearly. But without a doubt, we're not inventors, we're discoverers. And what we are doing is building upon what other people have done. And within the team, there were people that knew chemistry and assembly and electronics and testing and software, and people who could take a pencil and make a drawing and come back in 2 hours and have something that was run out of the lathe or out of a thing and put it together.
As HP's inkjet supplies business unit moves into a third generation of increasingly complex pens, there is an appreciation for the early daring of the St. Helens team. Their willingness to take risks led to the concept of a disposable pen, a radical idea 10 years ago for Hewlett-Packard, a company that had built a reputation on creating products that would last a lifetime. The 10-minute, $10 service call became HP's battle cry, reflecting the customer's ability to simply replace the print cartridge in case of failure. With the go-ahead to pursue thermal inkjet technology, a debate grew. Should they change the basic design of the device to achieve greater printing speed? Changing John Vaught's design to a straight-shooting nozzle device provided room to lay down rows of ink nozzles and the chance to greatly improve printer resolution. Finally, one day, project manager Frank Cloutier decided to give something new a try.
And I took a piece of aluminum foil, put the tiniest hole I could in it from a pin from my wife's sewing cabinet, placed that over a resistor, and looked under a microscope with a strobe on it to see if it would work. And lo and behold, it did. After a while, though, it stopped working, and we wondered if once again we had a reliability problem. So I moved the chair back, looked at the apparatus, and lo and behold, the microscope was covered with ink, I was covered with ink, my suit was covered with ink, and so a few suits of clothes and several tries later we had the original architecture that we still use today.
From that point on, research concentrated on developing a multi-nozzle design. No one was more anxious than project manager Ernst Ernie to see words on paper. He jokingly promised to buy hamburgers for the St. Helens team when they finally delivered the first printout. Directing the ink as it exploded out of the cartridge would be the next challenge. A nozzle or orifice plate that would channel the ejecting ink onto the paper was the answer. Engineers Paul McClelland and Gary Sywell recalled a process called electric forming, which they had seen when working together years earlier at Tektronix. The electroforming process includes applying a thin layer of metal to a flat orifice sheet mold called a mandrel. When peeled off, the metal produces an exact copy of a sheet of orifice plates. Shown here are a mandrel and orifice sheets for the St. Helens on the left and a set from the Candide pen on the right. When St. Helens was introduced to the market, engineers were already working on the second-generation Stanley pen. The addition of more nozzles for better print quality resulted in a new manufacturing step called tab head assembly.
One of the key problems that we had with the Stanley head as it was being developed was it was huge. Another problem that we had was there's so many interconnects here in between the paper in the head, and we wanted to reduce that. So the solution that we had was basically take the active area in the resistor area, make that the part of the silicon we used, and then all this interconnect down in the bottom here, put that on a flex circuit, and then bend that underneath. So that gets you out of the way of the paper.
It wasn't long after the St. Helens team started that they found Niels Nielsen's equipment too large and too noisy for the technology trailer, and the trailers proved too bright for his microscope. So he set up his lab in a janitorial closet in the building next to the trailer.
So in the earliest days, we didn't have enough room for the technology. We were just starting the technology off, and we found a broom closet that was literally just off of one of the restrooms that HP had there.
So here we are in Building 3 upper. The trailer used to be outside those windows and downstairs, so we had to walk all the way into the building here, down towards the bathrooms, and this is the broom closet. And I haven't been back since they moved us out in 82 or 83, so we'll just step right inside. And here it is. The lab bench was right against this wall.
Now, I was walking to the test area one day. Somebody was in front of me getting a drink of water. They left, and I heard the water cooler come on, and Niels cussed. And I thought and said, no way.
And we skidded the bench in, and we did all of our pen testing right here. This is where we had all of the failures that we couldn't account for until we figured out that it was a water cooler.
And every time the compressor on the water cooler turned on, it sent a power surge through the system that burned out our print heads.
This is a water cooler right here. And it just started running.
So we found that early reliability was more determined not by the intrinsic reliability of the print head, but by how thirsty the employees were walking by.
When a pen design fails, it is the job of autopsy or failure analysis to find out why. The feedback they then provide to the engineers and technicians has a direct effect on future pen reliability. Reliable and affordable substrate materials for thin film development were what Mazzio Laban and his colleagues were searching for in the early 1980s. During his search, Mazzio came across a box of square glass plates. The question quickly became, why not glass? By the time second-generation inkjet pens were being developed, silicon had become an affordable resource and is now used for pen printheads. One of the most fundamental materials used in thermal inkjet is the ink. Devising an ink that would hold up to the demanding thermal inkjet firing process was one of the most complicated challenges to overcome.
Okay, one of the things I remember so clearly about the early trailer days was hanging print samples up on the walls. Every time we had a print sample, we thought it was a major breakthrough, so we'd put it up for Frank or for Ernst to see. Well, one night when we left, somebody had left the windows open. A storm came through, and the rain came through the windows, of course, and took all the print off the samples. It was funny the next day when I was looking at that mess because it seemed like anybody would have known that was going to happen, only we just never thought about it until after the fact.
So after the fact, then what did you do?
Well, then we made sure that the windows were closed, and then we started thinking about print fastness and light fastness and all those other issues that we just forgot about and never even worried about.
Since then, ink labs in Corvallis and San Diego have created 21 different inks, with new formulas continually being developed. The intense focus of the St. Helens engineering team had quickly harnessed thermal inkjet into a workable pen. But preparing each interconnected element of the whole for high-volume assembly required years of commitment to designing IJBU manufacturing practices. While the process may have been new to HP, the commitment was not. 10 years later, the ramp is steeper. With advancements in inkjet technology, new pens move into high-yield production in as little as 18 months. While many of those manufacturing innovations are technical, IJBU has also endorsed new methods and styles of communication and organization.
There aren't very many organizations in HP that are as large as IJBU, especially IJBU manufacturing. So we've had to pay special attention to figuring out how to make a very large organization work well together. And so I think we're probably pushing the envelope within Hewlett-Packard.
After years of work, the St. Helens pen was going into production. Crews were trained, materials were ready, equipment was online. But at the 11th hour, pens began shooting wild.
So someone had the idea, what if we put in some little elongated openings that might act as shock absorbers? And that was a great idea, and everyone thought it would work. The problem is, to create a new mask to put those in there would have taken weeks. And what I ended up doing was taking 5 slotted features from a different mask and imprinting them on the orifice mask and creating those slots in about a day and a half.
Although HP was introducing a new printing technology to the world of communication, the first St. Helens production team had to rely on manual assembly to build the first pens. Cleanroom technology has also evolved.
Things weren't so high-tech back then. We had to hold the die in place manually so we could glue them into the pen body. We rigged up a plate with 4 sets of tweezers attached. This way we could glue the 4 print heads at a time.
There has been a steady trend towards automation to increase yields and efficiency and to prevent ergonomic injury. The first fully automated cleanroom assembly, called the Fast Fab, is at the Corvallis site. The first IJBU automated production line was produced by the Bodine Company out of Bridgeport, Connecticut. They had worked previously with the San Diego division to assemble plotter pens, and now Corvallis engineers wanted the Bodine's basic chassis to be retooled to manufacture the St. Helens pen. For years after their arrival, the Bodine machines were known as Pat and Harry, in honor of Harry Griffin and Pat Shelley, the tool and equipment designers that guided them to productivity.
Well, back in the 80s, we'd tour HP executives through the Bodine facility quite often, and the impression they left with was every time the Bodine would cycle 2.3 seconds, it was $5 for HP. So it was $5, $5, $5, almost like a locomotive. So it was a pretty impressive deal.
Bodine package, drive and brake. Bodine package, drive and brake. 500K a piece of cake. 500K a piece of cake. Working hard here every day. Working hard here every day.
To date, production lines have ramped up in Corvallis, San Diego, Singapore, Puerto Rico, and in Ireland as of 1996. Production has shifted from conveyor line operations to modular units, and assembly time for one pen has been cut in half. By August of 1988, Corvallis had the St. Helens and Stanley into production, while San Diego manufactured the squirt pen. As a production incentive, upper management set a goal. If all the lines together built 500,000 pens in a month, they would swim Corvallis' Stewart Lake as a group. 1 year later, with Singapore in production, the 3 facilities reached 1 million die. This would be the first time of many that management would jump in the lake. Many people at HP believed in the potential success of thermal inkjet. None believed in it more surely than Dick Hackborn, the man then in charge of inkjet components operations. Much of the hard work in pen manufacture was a result of the success of the DeskJet printer, introduced in 1988 as HP's first plain paper inkjet printer. Sales of the DeskJet were sluggish at first, but when Dick Hackborn pushed the decision to cost-reduce the printer, sales went through the roof, and so did pen production. The designers of this exhibit took an oft-used IJBU phrase, the wall of pain, to represent all the obstacles the production team have had to surmount to meet that explosive market demand. Those in marketing also had to forge a new trail as the popularity of HP's products grew. Ad campaigns have shifted focus from the specialized world of computer gurus to the needs of home and business users. Since that first pen and printer were introduced in 1984, over 52 inkjet pens and 20 printers have been introduced into the marketplace. Today, Hewlett-Packard is positioned as the leader in the inkjet printing business. That success has presented new and different challenges that will require bridging the past with the future.
This one down here is pretty much said. There's the panel goes here, and then again there's vinyl cut copy here.
became aware of the importance of stories and connection around the history of an organization, how important that is to the new people in the organization so that they all become part of the family, so to speak. IJBU typically has over half of its employees here within the last 2 years. So that's a significant opportunity to, or challenge, to have those new people feel like they're part of the whole story or the whole organization as opposed to just what's happened in the last 2 years. And so that was my, or I guess the genesis of my desire to try to bring something like this wave of innovation, or the story of how this got started, so that people could see it, see what people did. They know most of these people are still here, and get a connection to the whole that now they become part of.